Welcome to the 2024 Lattice Developers Conference. In this session, I will be discussing the Lattice Drive, Paving the Road to the Future, features and functions. So my name is Mark Hoops, and I manage the industrial and automotive segments for Lattice. Been here for just about 4.5 years. Previously, I held similar positions at Intel Altera in industrial and embedded strategy, and at Xilinx in strategy and systems planning and vertical market management. Today I'll give a brief background on the different segments within Lattice, and then go into the Lattice drive stack, driver monitoring system, and summary. For a little bit of background on Lattice's business, overall, we break out different applications and markets. Communications and computing is approximately 35% of our business. Industrial and automotive is nearly 60% of our business, and consumer around 6% of our business. This is for 2023. And we have a very large, well-recognized, established customer base. You can see many of the big names here. But overall, we have more than 10,000 customers worldwide. As far as the FPGA market goes, Lattice is the world's largest supplier of FPGAs by volume. And we've also been supplying solutions and been in business for over 40 years. We offer global support with sales and customer support across the world. Now, in addition to supplying FPGAs, we also provide something called software solution stacks in order to enable our customers to more rapidly adopt our FPGAs into their solutions. One of the first stacks we designed and produced was SenseAI, which is all about enabling low-power edge AI for the industry. Next, we had Lattice mVision for embedded vision, cameras, and displays. Lattice Sentry focuses on cyber-resilient root of trust solutions. Lattice Automate is all about enabling factory automation. ORAN is for 5G deployments. And then the focus of this presentation, which is our latest stack called Lattice Drive, enabling adaptable automotive designs, focusing on DisplayPort connectivity, local dimming, driver monitoring, and bridging and networking. Here you can see some of the main elements of the Lattice Drive stack. In green, we've highlighted our first release focus, which is on infotainment, display, bridging, and processing. In addition to providing infotainment, display, bridging, and processing, our design software that allows you to implement functions into the FPGA is fully certified for functional safety all the way up to ASIL D. Now let's dive into some examples of Lattice Drive in the cockpit. So here you can see a fairly high-end modern cockpit, which has many, many different types of displays sprinkled throughout. On the left-hand side, there's a camera for an e-mirror with a local display. In the center, in order to maintain a driver's focus, you can have things such as heads-up display and a cockpit display. Off to the right, you'll have your classic infotainment kind of display, as well as the display potentially for the HVAC system. Now, these components are all connected up to a centralized infotainment domain controller. And this is where Lattice comes in, helping to maintain and connect bridging sensors and displays up to that centralized controller. So we can handle multiple different types of size and resolution and frame rates. We can support multiple interfaces such as LVDS, DisplayPort, and we can also go up to 8.1 gigabits per second or HBR3 speeds. In addition to displays, there could be cameras throughout the cabin. We can enable sensor aggregation of those cameras or other types of sensors. And then we also can enable ultra low power pre-processing or co-processing in order to reduce the workload on the infotainment processor and provide a more efficient low power solution for the cockpit. Now I'd like to highlight one of our solutions that we've developed called a scalable local dimming solution. First of all, I'd like to explain a little bit about what is local dimming and why people would implement it. I think a lot of us are probably familiar with the nice looking quality of OLED screens, but OLED screens don't have the lifetime and are kind of expensive for vehicles. So the best possible quality you can achieve that's closest to an OLED is called an LED display with adaptive local dimming. So behind the display, what you have is an array of LEDs and a bunch of zones. And you can control the brightness and contrast of the image overall by controlling that array of LEDs with sophisticated algorithms in order to optimize the picture. So what we're looking at here is basically on the left-hand side, you start from an infotainment processor and you output the content that is going to be displayed on the main panel off to the right. And what that does is we come into the FPGA and we bridge from an open LDI interface over to the embedded display port, which is what the panel accepts. In addition to doing the bridging function, the FPGA also enables the local control of the LED backlighting for the display in order to optimize the image quality. Besides doing local dimming, we also can do other image enhancement functions. We can do rotation, scaling, daylight enhancement for contrast, and we also can provide an integrated fail-safe mode for on-screen displays. In case of loss of source content, we can still display things like speed in case there is no video detected. Diving a little bit more into the local dimming solution, on the left-hand side, you can see a block diagram where we are performing in this demo. First thing we do is we bring in the video, comes in at a 720p resolution, and we upscale that video to 4K to match the panel resolution, increasing the quality. Then we also simultaneously implement the local dimming algorithm, and we're driving both the video output and the full array local dimming controls to the panel and this display. It's about a briefcase size display and nicely shows off the power of local dimming. If you look at overall benefits and features of the solution, for one, we can support a wide variety of LED displays. We can support LVDS, embedded DisplayPort, and DisplayPort interfaces. So you have different flexible interfaces. And we can also support a very wide range of zones and resolutions, all the way from few zones in HD, more cost effective, up to the maximum number of zones, literally thousands of zones and 4K resolution, which enables the highest possible quality, but at a slightly higher cost. And across that, we enable full supply chain flexibility. You can choose different vendors for your components. And you can see on the left and the right sort of the difference in before and after of the parrot image that shows the enhancement in the image from the local dimming. Along with the benefits of local dimming quality and flexibility, Lattice FPGAs in particular are well suited for this because they are much lower power, up to 75% lower power than competitive FPGAs. And our interface solutions are up to twice as fast as competitive FPGAs. Now I'll walk you through the drive stack. Starting at the bottom, we have our hardware platforms. On the left-hand side, you can see the modular FMC adapter. This is an adapter that takes daughter cards that you can see in the middle for DisplayPort, transmit or receive, embedded DisplayPort, transmit or receive, and multi-gigabit Ethernet. And those cards then pair together to enable various different video IOs or network IOs and plug into the Certus Pro NX PCIe bridge board dev kit. If you move up the stack into IP cores, we have DisplayPort, transmit and receive, FPD link, MIPI D-PHY, MIPI CSI, 2, transmit and receive, MIPI DSI, receive and transmit, an LPDDR4 controller, video scaler and video frame buffer, and we recently are enhancing some of the DisplayPort features and enabling some image enhancement IP and local dimming demo with LED driver designs. On the software tool side, we have a standard Radiant design software, Lattice Propel, and for AI-based designs, we leverage some of the SenseAI stack capabilities. Moving up to reference designs and demos, we have a DisplayPort with video scaler reference design, MIPI DSI to DisplayPort reference design, embedded DisplayPort with video and scaling and local dimming demonstration, and then DisplayPort and video scaler demo, and finally a driver monitoring system demo. Looking to forward, we will have GSRD and video bridging, image enhancement, and local dimming demo and LED driver reference designs and demos that we're showing. And last but not least, for custom design services, we can do design services around local dimming and LED driver projects, and also engage with customers on driver monitoring system and other AI applications for vehicles. And last but not least, we're looking at automotive bridging and networking for future. Now I'd like to talk a little bit more about driver monitoring systems and why they're so important. First of all, distracted driving is the #1 cause of accidents in the US. 80% of the accidents are caused by distracted driving, and 65% of the near accidents. Things like talking on a cell phone and texting are recent ones, but also reading, eating, applying makeup, you name it. So it's really important in order to prevent accidents to provide warnings and reminders that the driver should pay attention. You can see a kind of a almost funny, laughable picture of a very distracted driver up there to the right. Hopefully not too many people of us are doing that. It's pretty extreme. In addition to being a safety measure, it is becoming mandated by different agencies around the world. In Europe, it's the Euro NCAP driver monitoring requirements. And in the USA, the NTSB is recommending driver monitoring systems for vehicles. And it's pretty much recognized that whether or not it becomes an absolute requirement by law, it'll effectively be a de facto requirement because of safety ratings that will be affected by whether or not you provide driver monitoring solutions. For example, if you have even a 5-star crash rating, but you don't offer driver monitoring or other ADAS systems in the car, then maybe the maximum kind of safety rating you could get would be a 2 or a 3, instead of you would have previously maybe had a 5-star rating for just the crash detection. So it'll be very important in the future for that purpose. And on the lower right-hand side, you can see the adoption rates climbing very high, approaching nearly 80-85% over time. And what's going to happen is in blue, you can see the camera-based systems are the main growth factor. The inferred systems are things that, for example, make sure you have your hands on the steering wheel and you're actively sort of correcting for the car as it moves down the freeway. But those are going to be replaced eventually into more rich systems that are camera based, that can actually look at your face and your eyes and make sure that you're not asleep, make sure that you're looking forward, and make sure that you're actually paying attention and alert. Now I'd like to provide a little bit of background into some of Lattice's leadership positions and capabilities in computer vision and edge AI. So we've been engaged primarily initially quite a bit in the client compute market, deploying edge AI solutions for computer vision and AI into client computers, laptops, and things like that, sometimes smart consumer devices as well. We've also deployed into industrial HMI solutions, robotics kind of areas. And for the automotive side, driver monitoring system and surveillance kind of applications are key focus areas. And in all of those areas, some of our primary capabilities that we focused on are things such as human presence detection, enabling depth sensing to understand how far away a person is from a sensor, ensuring we have the best-in-class 3D head position and gesture tracking, Face ID and landmark tracking, eye feature detection and tracking. We also enable human skeleton detection, object detection, and we've adapted our client monitoring solution into driver and in-cabin monitoring scenarios. And we also supply a solution that enables AI in the camera, which allows you to do surveillance monitoring, enabling a low power sentry mode where you can monitor the external parts of the vehicle. So I'd like to dive in now to a little bit of details around our driver monitoring system demo. We can support a camera with 720p 30, infrared or RGB. The compute platform we're using for the demo is Raspberry Pi 5, and the Sense AI vision engine runs on top of Linux. It's an out-of-the-box demonstrator, show it off at different trade shows, and it's gotten a lot of good feedback and attention. And then for the driver monitoring solution, the benefits of our solution are we are both sensor and hardware agnostic, meaning we can work with many different cameras and many different types of hardware. We can implement some things in software purely, or in software and hybrid, in FPGA as a hybrid kind of solution. It's optimized for very high accuracy and the lowest computational footprint. And it's also secure. It's implemented at the edge. You don't need to send anything up to the cloud, so everything is local. And last but not least, many driver monitoring systems that have been out on the market have been evaluated by third parties, and the results are, let's just say, less than stellar. So there is an opportunity for continuous improvement, and we think that, especially with our expertise and quality software, that we can provide a better solution and more flexible solution overall for the driver monitoring market, which is very rapidly growing. Moving on to EVE, also known as Edge Vision Engine. So there are a couple of different major modules in the Edge Vision Engine. One is the Action Recognition and Scene Understanding module, which you can see on the top here, with examples such as object detection plugin, background segmentation, and hand gesture plugins. And if you look at the lower module, the HMI module, we have things like face and person detection, 2D landmarks, fatigue, gaze, attributes of the face ID, and image enhancement type of modules that we can supply. And so that's all the things that are available in the Edge Vision engine on the left in the yellow boxes. On the right, the customer or client can use that engine to determine what engines to run on which images and what types of raw data they would get out of the solution overall. So basically decides which accelerator to run on and what algorithms to run. It can manage and control the camera, and they can use this to complement with their own algorithms and develop various different use cases in a flexible manner. Now we'll take a look at some of the key reasons why customers would be better off working with Lattice because of the unique kind of capabilities in our offering. So first of all, they would be partnering with a very well-established, financially stable organization with significant AI software and hardware resources and investments, which would remove any kind of potential long-term risks they might have with smaller, less financially stable type of suppliers that are in the industry today. Also, we provide an open platform that enables customers to develop their own system, providing control over their own destiny. Most of the solutions that exist today require you to be 100% dependent on the supplier for any kind of features and functions and any kind of enhancements or differentiators you would like to do. Whereas by working with Lattice, customers can take control of their own destiny and be able to manage their own roadmap with or without Lattice help. We have a great system of tools to support development, to customize and differentiate the solution, either in software running on any different processor or in a hybrid environment such as using a software with an FPGA to enable lower latency or lower power types of benefits. Customers can keep ownership of their data. Customers are very protective normally of their data. And they can balance workloads between low power and higher compute flexibility in the SoCs. We also have a collaboration model that allows customers to get access to Lattice's low compute footprint AI and domain experts. It's a key differentiator. While many people are capable of implementing algorithms and AI, it's quite a different sort of talent to be able to optimize the algorithms into the smallest possible compute footprint, whether it be in the CPU or in the FPGA, to minimize resource utilization and power. So customers can develop their own solution using our technology, or they can leverage Lattice domain experts to support their own development. And we can also help them jointly develop the solution. So the DMS solution on the lowest cost